Stormwater management is an important component of any city's resiliency plan. Stormwater, the product of rain and snowmelt coursing through a city's drains and discharge pipes, can contribute to flooding and pollution. This runoff can attract non-point source pollutants from impervious surfaces like roofs and pavement, carrying them to waterways and jeopardizing the safety and ecological health of the watershed. In order to understand Portland's stormwater management system, we must first develop a context of the city's geography and climate. Not only does Portland sit at the elbow of the Columbia and Willamette rivers, the city contains a detailed vasculature of 300 miles of rivers and streams. With 3 feet of rainfall in a typical year, Portland risks polluting its watercourses and flooding its low-lying districts. As a result, Portland has been proactive in mitigating stormwater through a campaign promoting green infrastructure. In contrast to gray infrastructure like pipes, green infrastructure utilizes nature's ability to soak up rain and purify groundwater. Green infrastructure features, like rain gardens and swales, use biotic elements like trees and soil to capture stormwater in urban environments. Green infrastructure is especially lucrative for its co-benefits, including attenuated heat stress, improved air quality, food production in community gardens, habitat, and quality of life, the intangible benefits to well-being. Portland has a variety of grant-based programs and incentives to accomplish green infrastructure projects, which will be discussed in 2 case studies. However, it is worth pausing to address how these policies are financed. Portland has a stormwater utility that can be found as a surcharge on the month's water bill. Each residence is responsible for paying a flat fee, usually around $20, in addition to an area-scaled charge for impervious surfaces like driveways. Moreover, new developments are subject to a systems development charge, which can be several $1,000s. However, the city awards discounts to the Clean River Rewards program, which eliminates up to 100% of the utility for qualifying green infrastructure projects on the ratepayer's residence.
Flooding is a major threat to Portland's residents and infrastructure, making stormwater management extremely important to the city. The city's position at the intersection of the 2 major rivers of the Willamette River and the Columbia River makes it a prime target for flooding. Flooding can not only have costly financial impacts, but also take away homes and ravage communities, leaving irreparable damage. Flooding in Portland is caused primarily by heavy rainfall, but severe floods can occur when a combination of weather events align to create a perfect storm scenario. Aside from rainfall, heavy snowfall, deep freezes, and heat waves can also contribute to flooding. As a result of climate change, instances of such extreme weather fluctuations are predicted to become more common. However, the Willamette Valley has always been naturally prone to flooding. Human development over natural floodplains and wetlands has put communities in harm's way. Without natural floodplains, the Willamette and Columbia rivers can overflow and cause more damage downstream. Some of these communities are protected by levees, but these levees are aging and many residents fear the day they might fail. One instance of a severe flood was the Willamette Valley flood of 1996. After a winter of heavy rainfall, a week-long period of heavy snowfall and deep freeze hit the mountains of western Oregon. In early February, a warm jet stream melted the snow and brought more heavy rainfall. The saturated soil was unable to absorb all of the water, and the result was a rapid flood in every body of water in the region. As a result, over 20,000 people were evacuated, 10,000 homes were destroyed, hundreds of cattle were killed, and $27 million of damage was done to highways in the Portland area. President Clinton called a state of emergency in the region, and thousands of civilians and National Guard officers joined together to build a makeshift seawall to protect downtown Portland. However, the effect of this storm is still felt by residents over 20 years later.
An example of green infrastructure that is aimed at addressing Portland's heavy flooding and rainfall has been the Green Street. A green street uses sidewalk gardens to manage stormwater, reduce flows, improve water quality, and enhance watershed health through utilizing the natural systems of plants and soil. Green streets protect water quality in rivers, streams, and groundwater by removing up to 90% of pollutants while retaining 94% of storm runoff. These bioswales, the term for pollution filtering landscaping, divert stormwater from storm drains and sewage system to a more direct and sustainable method of management. In April 2007, The Portland City Council approved a Green Street resolution, report, and policy to promote and incorporate the use of Green Street facilities in public and private development after 4 years of piloting the project. The project specifically aims to reduce polluted stormwater entering Portland's rivers and streams, improve pedestrian and bicycle safety through curb extensions, and reduce the demand on the city's sewer collection system and the cost of constructing expensive pipe systems. Green Streets also help create for a more livable neighborhood through the added greenery of the infrastructure. Locations for Green Streets are chosen by the city through surveying neighborhoods where problems of basement overflow and stream pollution, among other criteria, are worst. The built infrastructure is maintained monthly by Portland Environmental Services. Since the project's inception, there have been 1,300 Green Street bioswales, which filter 125 million gallons of stormwater annually.
To help manage stormwater, Portland encourages the use of eco-roofs. Eco-roofs are designed by replacing typical roofing with a waterproof membrane and layering a drain mat, soil, and vegetation on the roof. Most stormwater is absorbed by the vegetation, which limits the amount of water entering the gutter and stormwater drainage system. Portland provides extensive guides on how to build eco-roofs by yourself and provides information on where to find developers to do it for you. Eco-roofs provide many benefits along with managing stormwater. The vegetation absorbs carbon dioxide and air pollutants. This reduces the urban heat island effect and improves air quality. The roofs also reduce the amount of runoff entering water systems and erosion. This helps maintain drinking water sources and animal habitat. The roofs also provide increased biodiversity and green space within the city. Finally, they help reduce the building energy use by providing heating and cooling during different seasons. Portland has seen tremendous success with the implementation of eco-roofs. In 5 years, Portland has allocated $2 million in grants to 130 new eco-roof projects. The projects spanned over 8 acres and annually manage about 4.4 million gallons of stormwater. Portland has been able to mainstream eco-roofs by providing business economic incentives for developers. For example, the city uses grant money to make eco-roofs cost as close to $5 per square foot as possible. This changes project to project, but has had wide success throughout the city.